More, and one of the most fascinating stories that came out last week was the greatest mind of the 20th century actually wrong about something. Scientists at the world's largest physics lab say subatomic particles have been observed traveling faster than the speed of light. That contradicts Albert Einstein, which makes the claim a pretty big deal. Joining us to explain what this all means is Robert Ehrlich, professor of physics at George Mason University. Thanks for coming in, sir. Good to see you. Good to meet you.
My pleasure, Tony.
All right, here's the first thing that I guess we should make clear. As I understand it, before we even get to the details of this, this has to be replicated by some other scientists before we can take it as a given. Is that right?
Sure. Anytime anybody comes along with an extraordinary claim like this, nobody's going to really accept it unless it is replicated.
But there's no reason to believe that these guys are lying or anything. You just need to prove it in another facility and in another way.
Yeah, they have no motivation to lie. They would just look like fools. But let me tell you a little bit about exactly what it is that they did.
Okay.
This is not some experiment done in somebody's garage, of course.
Right.
What was done basically is to create a beam of subatomic particles called neutrinos, send them across a distance of some 500 miles, and then observe how they would arrive compared to a beam of light covering the same distance. What they found is that in that 500 miles, these neutrinos arrive 60 feet ahead of a light beam. So they're beating the speed of light by a very, very tiny amount.
Although, yeah, because I read it was 60 nanoseconds, but when you put it at 60 feet,
yeah,
that's actually pretty significant, it seems. I mean, it's minuscule over 500 miles.
It all depends on how accurate you can measure the discrepancy. And they claim to measure the discrepancy to no more, to uncertainty of 10 feet. So that's a very significant deviation.
Okay. How are subatomic particles sent 500 miles and captured someplace else? How does that even work? Are they just traveling through the air?
They are traveling through the air. The particles they use, neutrinos, can actually travel right through the Earth. In fact, this very second, trillions of neutrinos are passing through your body. You don't feel a thing, of course. These are really very unusual particles, these neutrinos. And they've had all kinds of fascinating discoveries that took decades to demonstrate.
Yeah, my understanding is that they can assume different shapes and all that kind of thing.
They can assume what they call flavors, different flavor neutrinos. I should mention that the possibility of faster-than-light travel was first raised in the 60s, as long ago as that. And most physicists kind of gave up on the idea because there's been a series of false reports over the years. In terms of where things stand relative to Einstein's theory of relativity, people should be aware that even though Einstein did say that nothing can exceed the speed of light, what he was referring to is to take a particle from below the speed of light and accelerate it to the speed of light and beyond. That is impossible.
That is
impossible.
Impossible. Okay.
However, the way one can get around this, these researchers in the 60s proposed, well, maybe these things are always created at super light speed from the very moment of creation. And if you accept that, then you would basically have three classes of particles, those always below the speed of light, those always above the speed of light, and those right at the speed of light. So it's
kind
not
of first class, business class, and coach.
Yeah, yeah,
okay.
With strict separation between.
Of course, of course.
So in that sense, there's no real fundamental disagreement with relativity.
Okay, let me ask you two questions because, you know, the media, we like to simplify things and everything. All I heard talk about this weekend was time travel.
Yeah.
If we can duplicate what these scientists have performed, does that mean theoretically time travel is possible?
Well, let's see. Personally, I don't think so.
Okay.
It's not that I would categorically say that time travel is impossible, although I think it's exceedingly unlikely. The other thing that some people have suggested, if these particles are really traveling faster than light, is they could be used for signaling backward in time. There's a great movie, I don't know if you saw it, Frequency, with Bill Willis, where he receives messages from his dead father.
Right. Bruce Willis? Was it Bruce Willis?
I think it was Bruce Willis, yeah. I don't think that is possible if these tachyons exist, but they do have some really bizarre properties. In fact, I might just add that a decade ago, I actually did some published work which suggested precisely the idea that tachyons might be faster than light. It was a different flavor of tachyon. There was, different flavor of neutrino that associated with the electron, but still, and the result was not conclusive, but still, it did raise this possibility. And other people have considered this over the years.
So we're going to have to watch and see what happens over
We just have to watch and see.
All right, Doctor. Thank you very much for coming in. I appreciate it. It helps us understand it a little bit more. Thank you.